welcome everyone. Thank you for being here today. I'm really excited to be here. Actually, I haven't been last year, and I love this conference. I really think it's like maybe the best conference, but I'm a bit biased. And also the program is amazing, right? Everyone agrees that the program is amazing. Program chair did a great job, whoever that is, he or she. I'm really happy to be here. So yeah, thank you for joining. And today I'm going to talk about reflection. So I'm sure, by the way, I'm probably going to stop sometimes in the middle because my breathing didn't adjust to Aspen yet. So I only got here last night. So I'm sorry if I'm going to have to pause. And then you can just shout stuff or just give me your comments or tell jokes. Feel free to do that as well. But only once. Keep in mind that the camera is on. So let me start. So thank you again for coming, and I'm going to tell you about reflection. And I think it's a very exciting topic. By the way, So first of all, welcome to the metaverse. So reflection proposals have been discussed in the C++ committee for quite a while. And I'm, by the way, for those of you who doesn't know me, I'm Inbal Levi. Great to meet you. I'm also Library Evolution Chair for the group that is in charge on the standard library design in ISO, in C++. And I think it's a very fascinating topic because I really think it's going to have, you might think of reflection at first as a language feature. So first of all, you're going to be surprised because there's quite a lot, I would assume like quick estimation of around half of the proposal is, for the very least, is wording related to library because we do have quite a lot of meta functions there. And those are not regular functions. Those are functions that need compiler intrinsic support, but still it's quite significant. And the second aspect that I think is really related to libraries is that I really expect a lot of libraries coming up in the upcoming years using this feature. And that was my main interest when exploring this or taking this under consideration. And I really think it's interesting to think about that as well. So take a second to breathe. Sorry again, Aspen air is hard. So as I mentioned, my name is Inbal Levi. I put here a QR code. Actually, unfortunately, I didn't. I forgot to post the link in Discord. So if any of you feels like posting the link in Discord, please feel free to do so. But I put here a QR code for the slides. And the main reason is I want you to be able to follow, but also there's Godbolt links in the slides for examples. And that's pretty awesome because even though we don't have the feature yet, we do have implementation in Godbolt online available. And that's due to our implementers. So I want to take this opportunity to thank White Charles and David van der Woede from EDG for working implementation on EDG compiler, and to Dan Katz from Bloomberg, which drove the implementation for Clang. And those people are really have done a lot of work. And also, they are the reason that you are able to actually go into the Godbolt links during this talk and experiment. So I think they really deserve even circle, clap of hands or whatever. Thank you very much to them. And I wish they were here, but that's fine. Okay, so as I mentioned, I'm Library Evolution Chair. I'm also a software engineer, C++ software engineer, quite expectedly. I recently joined Microsoft to the OS internals group, Windows internals. I'm also ISO Foundation and Boost Foundation board member. And as I mentioned, a member of the C++ committee as Israeli National Body Chair and Library Evolution Workgroup Chair. And I really think, in a sense, there's quite a lot of work that I've been doing that reflection can help to from different aspects of parts of my career. I've used to be an embedded developer, then worked on application level and in financing, and now I'm working on OS internals. So I really think that gave me also a comprehensive look to that. So what do I mean when I say reflection? Let's think about it for a second. So reflection is the ability of a software to expose its internal structure, right? And you might be familiar with reflection from languages like Python, but Python reflection is really different than what we're going to have in C++, hopefully in 26. And by the way, Rust as well, and I'm going to address that briefly toward the end of the talk. I'm going to mention Rust. But yeah, compiled languages and static reflection is a different thing than what we're used to think of for Python, for example. And that's, of course, addressing things like performance or security concerns, in a sense. Because what happens when we have static reflection? Oh, by the way, we have a compiler implementer here to us. Hi. Great, thank you, by the way, for working on Clang. So what happens is that the compiler basically looks at the syntax for reflection and generate a valid C++ code, right? And then the code is being compiled, and we get the binary, and we get nothing left in the binary to signify the fact that we actually used reflection to generate this code. So that definitely addressed things like security concerns, unlike runtime reflection. Sorry, yeah. I also wanted to point out, it's possible to use this feature to carry this information to runtime. It's not that users can't write code to capture this information, but it's definitely not part of the feature. And that's something that we did consider quite significantly in the committee. So this talk also have David, I think, here, that gave a talk on reflection last year that I'm really, really, oh yeah, hi. That it's unfortunate I missed, because I actually really wanted to be at that one. But this talk is not, I'm not going to dive very, very deep into the implementation detail of that. First of all, I'm not a compiler implementer. There's others that may be doing this better. But also, I think it's a lot to think about regarding this feature in the concept of software development. And I really wanted to give you a lot of this information, and it couldn't fit to all of this couldn't fit to a single talk. So what I'm going to do in this talk is, first of all, I'm going to introduce you to the syntax. So we're going to see a brief history of how we got this point, but then we're going to go over the reflection proposal that actually made it to C++26. Now, I mentioned before that I'm involved in the committee. We're now in a very interesting part of the process of publishing a programming language, the standard for C++26. We're at the feature freeze. That means that we're already settled for all the features that are going to make it to 26, but there's still going to be possibly quite a lot of fixes. And yes, it is possible that this proposal will be pulled out at the last second. So please take this with a grain of salt. I'm saying here throughout the talk, for C++26, it's because I do believe that it's going to make it for 26, but that's not guaranteed. So yeah, we're going to look at the latest proposal, the one that we're actually going to get. And by the way, also latest changes in that proposal. We are now at R11, by the way. And we're going to see a few usage examples of what I think reflection-based libraries are going to look like, because I think it's going to be very interesting. As Anna mentioned, it's one of my interests. Second part of this talk, we're going to talk a bit about the impact of our code bases. And in that point, I would love way more participation from you, because this talk is also about bringing up ideas and considering them. And I really want to hear your thoughts as well. So reflection as customization mechanism, basically, I will mention the term customization point, but I would not go deep into that, but I'll definitely mention that. I do have a talk from 3 years ago, I think, in this conference, so feel free to watch it. And then I'm going to talk about pipeline integration. There is also going to be some modifications in that, again, because of the properties that I mentioned on reflection being compile time, and talk about a bit what's next. So again, I wanted to point out the implementers, thank you for them, and also the paper authors, I'm going to mention them by name. So let's start with a brief history. We want to understand how we got here, right? So reflection was mentioned in the realm of C++, in the area of C++. First mention I found in 2006, but that was by Mitush Kolchik, and he had a mirror reflection library. So that would be something that you're familiar with as template metaprogramming library that uses typecrates, things like that, in order to explore our program. In 2012, we had a paper from Mike Spartus, which, by the way, is a great person to chat with because he's been involved in the committee for quite some time. He also gave a talk in our local conference, Core CPP, in 2023 about API with cloud, which I really recommend you to watch. But back then, he published a paper talking about the use cases. So I want to hear from you before I expose what he said. Do you want to, you can shout or you can raise your hand or whatever. Give me some ideas of use cases for reflection. What do you think you could use reflection for?
Serialization.
right? What would you?
Enums.
Enums.
Stringifying. Yeah.
Right. Anything else? Come on, try harder.
No,
There's a lot of them.
That's it.
Dietmar here is
Dependency injection.
in the
Right.
role
Hundreds
of
of
being
things.
pessimistic.
Standard.
So we've been working really hard to basically give you a tool for serialization and enums, but congrats.
Dependency injection.
What, sorry?
Dependency injection.
Dependency injection, right, or actually customizations in general. Right, okay, so use cases that Mike Spartus, and I've edited this a bit because there was something there that addressed proposals that currently don't exist, but serialization, delegates. Delegates is basically, I think, he was using this term in a different way to say wrappers in a sense, or pimple, things like that. Getters and setters. If I have a class and I want to basically add getters and setters, which is quite trivial, straightforward thing to do, I might want to use reflection as code generation mechanism, and customization points that I mentioned, and I'm going to address a bit further in the future. But yeah, use cases like that. Of course, there's many more. We're going to consider those in relation to the current proposal. Between 2014 and 2016, Matoush was trying to propose his library to the standard. It didn't went so well, and I'll give you the highlight of why. So in 2015, we had implementation by Louis Dion on a library called Boost HANA. And that was, by the way, if you have, a lot of people here have been involved in the committee for quite some time. If you have more details, feel free to come up with them or talk about your experiences. But generally speaking, this library was, again, heavily relying on template metaprogramming. And at that point, we found out that template metaprogramming is not necessarily the best tool to reflect on your code. And there's two main reasons for that. First of all, how do you like the error handling, of template metaprogramming?
Love it.
Is that good?
Better than it keeps me employed.
Oh, wow. That was recorded. But we got concepts. So anyway, yeah. First of all, yes. Errors from template metaprogramming is usually focused on technicalities of, like, let's say this template wasn't instantiated, things like that. And you want to have a higher level. When you write code, you want to have the errors coming from the logic of the code you've written, not from the mechanism. Second, and more significant aspect, is that it was just very much compile performance heavy, right? The compiler needs to work really hard in order to reflect on, using this mechanism is not necessarily the best tool. And we already know, without reflection, even for, like, I worked on a code base that was linker was failing because too many template metaprogramming and symbols, and that's not necessarily the best tool that you can use. So that brought us to basically thinking of specialized syntax for reflection. So in 2017, and you already see quite a lot of mentioning of papers, and that tells you how the amount of interest in this proposal. We got what we call now static reflection, already addressed to, and those proposals were already going in the direction of proposing specialized syntax. And at that point, there was also the notion of meta objects. So I will get back to that soon. But yeah, also wanted to point out that in 2018, we had a proposal from Bjarne Stravstrup. Sorry, it's not proposals, like a paper talking about enumerating the use cases again. But generally speaking, that shows you that if the inventor of C++ starting to publish use cases for something, that means that it's definitely getting interest. And in 2018, we already got Reflection TS. David Senkel is around this conference, so feel free to reach out to him and also talk to him about that. But this work I'm mentioning because it definitely put the ground, a lot of the work that's been done there was led to P2996 that we're going to see today. So I mentioned meta objects, and I want to mention type-based and value-based and things like that. So let's think about, like, compilers. You parse the program and you try to represent this in a way, right? You try to represent the program in a programmable way, and have your multiple compiler implementers or language authors or things like that. So how would you represent anything, like, in C++? Like, try to think of you could generally, how do you represent a student? How do you represent any system that holds information on something else?
Objects.
With the type.
Yes, with a type, with a classes, with an object, with hierarchy, right? So you could consider, okay, just my computer went off, so I wanted to make sure you still see this. You could consider a hierarchy to represent your program. For example, I can have a type function, and I could inherit from that to say I now have a static function or a member function, and I could add properties, right? I could create a hierarchy to represent my program. But that turned out also to be, and there was a lot of discussion between compiler implementers, that was, again, quite heavy for the compiler. So what we ended up doing and what we ended up having is the stud meta info object. Stud meta info object is a single type that represent all entities in your program, and the values held by it are the ones that you can query. So that's how we ended up here. And one point that I also wanted to make is that we have much more context pair in the recent years, and I'm very, very happy about that and grateful. Let's see how many times. And I also want to point out, thank you for Hannah Desokova for working on context pairing basically almost the entire of the standard library. And I think it's great work. And also generally extending context pairability is great. But still, there's a lot of difference between the ability to have a specialized syntax to generate than just telling the compiler, yes, you can execute that on compile time. So it was definitely helpful, but not the whole feature. So a few more proposals about naming and syntax. I just wanted to highlight here that every time we talk about features, there's a lot of discussion on that. So if you're ever thinking of making a proposal to the standard library or language, be prepared. And again, a lot of discussion on value and type-based. So we ended up with, as I mentioned, stud meta object, stud meta info object as representing our entities of the program. And we have in 2023 what is now slated for 26, which is 2996 reflection for 26. Thank you to Barry Razvin, White Childs, Peter Dimov, Andrew Southern, Faisal, I don't remember his last name, and David van der Voorde. So thank you very much to them. And follow up on this proposal, we also had quite a lot of proposal exploring the use cases and usability. So by the way, you didn't say binding. I was hoping to hear that, but that's also a use case. And I want to thank Adam and Jagrut and others for working on those to explore the syntax. So basically, those took the syntax proposed in P2996 and tried to utilize it. And today we're going to talk about 1.5 years later, revision 11 of this proposal, and see what we're basically going to get to 26. Cool. So I've mentioned the general idea of what is reflection. I now want to show you a bit of syntax to get you, to get you into the mindset. So I have here a class, and this is some lib type thing, and I inherit from base 1 and base 2. Then that was the code that I'm going to reflect on, right? Then in the part that I'm trying to reflect with, let's see if that works. No, kind of does. Weird. Anyway, yeah. And now I want to reflect on that, right? So what I do is create this reflection expression, right? And this reflection expression is by lifting the lib type into the reflection realm, right? So what I do here is I take something from the C++ realm, a valid C++ entity, and I lift this to reflection realm, and I represent this with expression. So I have stud meta info object, right? And now I can take this, sorry, actually I shouldn't have called this expression, but something else, and now I take this thing and I give this to my stud meta function. So in this case, it's basis of, that's the function. And what do you expect to come back from this function? Just want to hear some people ideas. A list, right? What else?
Array.
Array. Why not list? Because you're in compile time. What else? Well, yeah, array or list. We actually get in a vector. Interesting, right? Well, this is actually this vector is not leaking to runtime, right? It's a context per vector. But long story short, we get in a vector, and the vector members is basically base 1 and base 2, as we see here. And if I reach out to the first element, I can get back base 1. that works as expected. Yes. Sorry, what's your name?
Dennis.
Dennis.
Is it can be concept? It doesn't have to be constival.
The functions are constival. The variables that capture are constexpr, and I'll talk a bit about that later.
Thank you.
But yeah.
That vector is a copy of the data, right? If I change it,
if you're changing it, well, okay. So if you're changing this in reflection, well, like if you're using reflection syntax, I don't think there's any significant reason not to be able to change. But you cannot leak this through runtime. It's not immutable.
You're losing the monitor.
It's not immutable. Oh, sorry. Yes. Oh, now I lost it completely. Sorry about that. And while you're other questions?
Yeah, I have a
Go.
question. So if
Sorry,
the
what's your
base
name?
of Mikhail.
Mikhail.
So if the base of returns the vector,
A vector of stud meta info object. Sorry, I should have said.
but you cannot just with the current constexpr, you cannot just store the std vector, right? Because it should deallocate.
I couldn't hear. You cannot just.
A std vector should allocate and deallocate,
Right.
right?
This
so
is
is it extensions of the
Yes.
constexpr and only for meta, but nothing else?
It is for any. Okay, so yeah, we as part of you're correct. That's exactly what I've tried to highlight here. As part of the work of this proposal, there was a lot of discussion on what do we get back. One option was we get back something specialized for reflection, like a different container. We ended up getting to the conclusion that the terminology that we need is basically vector. And there's no reason to make up a new container. I mean, again, you could technically invent something that would only fit, to use in reflection that you could extract from, like some kind of collection. But vector became constexpr partially, but only you cannot leak this to runtime. So you basically define the vector here. You execute your reflection code, and then it's not something that you could basically save.
When you say you can't, is that compiler enforced?
Yeah, like whatever. There are extensions there have been discussions on. Barry Rasbin has been exploring quite heavily the whole idea of leaking the allocations from compile time to runtime. But that's really premature. We haven't got to any. And others, by the way, as well. I think Hannah also is exploring this. But that's premature. It haven't been finalized, so let's not. But yeah, that's good points, everything that you brought up. So going back to reflection proposal. Reflection proposal have 4 main parts. You already seen the first, the lift. Second thing that we have is splicers. So I talked about taking things from C++ world and taking them to reflection realm and using them, right? And now we need a way to get back from reflection realm back to C++ realm, and that's a splicer. Splicer is extracting your information back. We also have stud meta info object that I've mentioned already. We need a specialized thing to basically hold all this information and query it. And we have a bunch of meta functions, quite a lot of them. So I definitely not going to go over all of those here. Definitely, actually, most of them I'm not gonna. But I do want to highlight a few things that I think are interesting here as well. So look at, there's names here, is private, is override, is virtual, is complete type, things like that. Does that remind you of anything that we already have? Sorry, is that an answer for?
It's a question. It reminds me of type traits.
Right? Yes.
I also have a question.
Okay, so let me just finalize my thought about type traits. Yes, so we've had extensive discussions on that as well. We already have type traits. Do we want to modify? Do we want to? So no, those things are understood meta namespace. They have compiler intrinsic support. And yes, they're similar, but they also are extended. You're going to see that there's other things here as well. What's your question? Sorry. And sorry, what's your name again?
Michael.
Michael. Go ahead.
This is a silly question, but can the reflection operator be overloaded?
No.
Why would you want to do that?
I don't know.
Oh my God.
I know why he wants that. He wants that because we're using operator overloading for other domain-specific languages. So.
Of course.
Hey, another one.
Okay. I don't know if we specified, but I think we should specify that not. But let me check that and get back to you.
And also,
that'll be a hard no.
Yes. I would definitely. I'm pretty sure that the specification says no.
What's its precedence?
No. Okay, that's also a good question.
Like unary prefix operator.
Yeah.
Same precedence as all the other unary prefix. Okay.
Right. Okay. Thank you, David. One more thing that I wanted to point out here. Oh yeah, sorry. So thank you for that. And yes, one more thing I wanted to point out. Okay, and you know what? I'm not gonna spoil that to you, but there's two operators there, right? That's kind of weird, but we're gonna get back to that later. So one more thing that I wanted to highlight regarding this proposal, the proposal have been modified quite significantly, and I gave this talk already. So I wanted to highlight the changes. I'm not going to go into, again, the details because I think it's going to take too long. But we removed a few functions, mainly functions that talk about generation of code. And we also, test type was interesting one, I think, but we removed it. And we also extended, instead of reflecting on expressions, we extended that to value, object, and function. And again, I'm going to talk about this a bit later. But generally speaking, expressions in C++, even constant expressions, are quite complicated. And we ended up finding out. So, so instead of reflecting on expression and trying to promise that we can do this, we've basically broke this into use cases. We also have define aggregate. It used to be define class. That's an extension. Sorry if I'm jumping back and forth. So define aggregate there, if you can see. Oh, sorry. Used to be defined class, so now extended for arrays and unions. Yeah, I think that's pretty much it, everything that we had here. So if you're following up on the proposal, those are the latest updates, and feel free to ask me later. Cool. So a bunch of meta functions. We're going to look at some of them later, but let's start with the reflection operator. So we used to have a single operator. That was nice. I liked it. But now we have two. So first of all, reason is that because we wanted to avoid disambiguate with different programming language. I'm not going to mention the name because I'm still a bit pissed. But if you want to use a nickname for this really cool operator, double caret, then you can use Jeff Bastin's nickname. He gave the nickname Unibro. This is not official. Please don't quote me in any CPP reference or something like that. But yeah, feel free to use this nickname, and that's the tweet. At that point, by the way, I want to mention that, again, the reflection proposal was a really lot of work from both evolution group and library evolution group, and I want to really thank them for the collaboration. So yeah, but going back to the lift operator, we have here, and again, I want to emphasize this because it's important. We have here something that comes from C++ world, which is a type. And we use the lift operator to lift this to the basically to the reflection realm, right? So now basically I have here something that represents int, but is not an int. And now the thing that I've just shown you, someone already shouted out that before. But what do you think? Is that okay? Will that work? I'm giving you a hint here.
Well, that auto-rexpr is a runtime value, right?
Uh-huh. So?
We need to add the context.
Right? Yeah, pretty straightforward. So now that I've talked for, I guess, about 20 minutes only about the fact that this is compiler feature, yes, you can easily recognize, yeah, we have to have those expressions or those variables represent the reflection as const expr. Yeah, go ahead.
Even if you're in a const expr function during const expr evaluation, you still can't do that. Is what I understand. Like you have to have the const expr in there.
Yeah. Because it's capturing information. You need to tell the compiler this thing you can use to calculate your reflection. Run your reflection logic on this thing, and you cannot tell that to the compiler without a const expr. Yeah, go ahead.
Can I have a meta variable that I'm, gonna go and assign to multiple? Because this is const. I cannot assign to reflect. Or what if I have an if and I want to assign to it? Can I do that?
It's not const. What do you mean?
Context.
Okay, but okay, fine. Okay, yeah, you're right. I'm not sure. No, I don't think you can actually generate your own stud meta info object by yourself.
I assign and then I iterate through the loop.
Yeah, you iterate through the loop, or you apply meta functions and you get a different stud meta info object from it, and But yeah, thanks for that.
You keep saying that the eyebrow operator.
Unibrow. But you can use lift.
But it's just an expression. It behaves like an expression,
right?
From what you've seen. So
yes,
it doesn't lift it into the meta world. It lifts into expression.
I'm not sure I follow what you're saying, but first of all, I'm using this to emphasize an idea, so I'm not. And there's not really There's not really a reflection realm. That's usage as an idea. Okay, I hope that addressed.
As far as I could be wrong here, but I think the idea is that the meta thing has a type that cannot. We don't want to code gen it, have a machine representation for it, so it should only exist in constant text.
But as a programmer, this is an expression.
Yes.
Right. Yes.
No. Any meta info or code that manipulates meta info is considered to be in the reflection realm.
Yeah. So
but
you know what? Let me stop the discussion for a second.
Well, very different.
Let me stop the discussion for a second. Maybe I've accidentally passed through this too quickly. The term reflection realm. Oh, I have 1 hour break. The term reflection realm and C++ realm are terms that I've made up. They're not in the standard in any way. The idea that I'm trying to emphasize to you is that you have a representation of your program versus your program itself, and I'm going to talk about this a bit later. But of course, if this confuses you, don't use this idea and don't keep this in mind. But
it's an expression with type and value.
Yes. Let's move back. Let's continue. Sorry. So I talked about the lift operator. I now want to talk about the splicers. So after I take something that represents my int, I take the splicer operator, and now I'm able to extract this back to C++ world, right? Because I want to be able to use the information, the meta info object, to generate parts of my program. So ignore the type name for a second. I'll talk briefly about that later. But again, as I said, for the idea of taking things from reflection and back to C++ world is significant here, because you can't always, that's not trivial in terms of, if normally, what I'm trying to say is, like, normally you could reflect and just extract information. But here we're also giving you an option to change your program, and that's not trivial. So let's, we had some discussion about what is this thing. So let's actually have this officially in the slides. What is the reflection expression thing here? Shout.
Compile time variable.
Oh, wait, so I had compile time variable. What else?
To the meta.
Student meta info. Yeah, meta, the namespace info is there, right? Cool. So it's a student meta info object that basically represents the idea of int, right? So what is this type name reflection expression? So I will tell you because I don't want to confuse you. The type name is just used for disambiguate in some contexts that you want to make sure that the thing is actually a type. But let's ignore this for a second. And I just wanted to use the canonical way to write this. But let's ignore this for a second and just look at this splice reflex expression thing. What is this thing? Yes? Who said that? Michael, right? Michael said it's an int. That's correct. Right. It's a very complex way to say int. But yeah, I'm only joking here. But I really wanted to give you this to kind of get this idea set in your mind that what we're doing here is basically declaring int a equals 42. Okay, so that's really cool. Of course, here you can see in line 1 what this thing is. In more complex program, you might get this expression from somewhere else, and you want to be able to extract this, right?
Can I pass it as a parameter to a function?
Yes, that's exactly what you're going to see upcoming in upcoming slides. Let me cut the question just a bit, and I do want to go over the slides, but I'll leave some time at the end for more questions, and please feel free to tell me to go back. Cool. So if you want to read more about the type name aspect, just go into a proposal. They've written it better than I could say, and that's very interesting just in context of disambiguating. But generally speaking, yes, you now have all the syntax that you need to basically start writing reflection. So you can now go into the Godbolt links and start writing. So we went over reflection operator and splicers. I already mentioned stud meta info. I did wanted to say, point out a few things interesting about the stud meta info object that I think are worth mentioning. And then we're going to see some non-trivial or non-intuitive facts about that. So let's look at that. Anyone recognize the thing on the screen? But I have compiler implementers here, and that's a hint. So someone that is not a compiler implementer, recognize the thing on the screen. I saw your hand. Sorry, what's your name?
Z.
Adi?
Z.
Oh, Z. Hi.
That looks like an AST to me.
Yes, that's true. Can you just try to guess which compiler? It's not really.
It looks like Clang.
Yeah, that's true. Thank you, Z. That's awesome. Yeah. Yay, I love being in this conference. Yes, AST from Clang. So yes, that's very cool. Clang give us a nice tool to see the AST, and that actually represents the program on the right here. So for those of you, for the 2, maybe 3 people, and including myself, a few years ago, that don't know, AST is an abstract syntax tree, the representation of the program that the compiler holds. So the front end takes the program and parse it, translate it to this representation thing, and the representation thing is being sent to the backend and translated into binary according to the platform you're compiling for. So I hope that helped. But yeah, I already mentioned the representation of the program. That's exactly what we have here, right? And that really relates to reflection. So we see here things like function, declaration, that's our main. We see things like variable, I, that is the name, and the int, that is a type, and also the L value, the fact that this is an L value. So I hope for you now, it now gets connected to stud meta info object and the fact that we're trying to represent the entities of our program. And definitely that's not a coincidence, but we're going to get back to that. So stud meta info can represent things like type and type aliases, functions, variable, non-static data members, enumerators. Those 2 lines are important. I'm going to get back to them. But generally speaking, objects and values, template namespaces, and namespaces aliases. So I have here another example. And now you're a reflection expert, so you should recognize this quite easily. By the way, I'm just going to point out that in other conferences, I usually just gave all the answers. Here, I'm actually asking you because it's more fun, and also because I know you're going to get it. So here I have basically, oh no, wait, sorry. Oh no, I removed this. There was animation here, and I was trying to expose this, but fine. Here I have an example. This example actually works. Unfortunately, I wanted this to not work and show you the first one. But what I wanted to highlight here is that the things, the reflection expression needs to be const expr. But there's something else here that I made const expr in this example. Anyone can identify?
One more. What's the question again?
What here is also const expr. It's quite straightforward. What am I trying to tell you here? I'm trying to tell you that the things that you reflect on also have to be const, right? Because we started the reflection proposal with const expr, with basically saying that const expressions can be reflected on. But we ended up with those 2 restrictions that you see on the screen. Objects permitted result is of a constant expression, and value with structural type the permitted result of constant evaluation. Those 2 things are narrowing of what used to be generally a constant expression. And the reason is that we found out that even in the constant expression realm, it's not as trivial to reflect on, and that was left for a later proposal. So again, in the first example that I showed you, we saw that this have to be const expr. Now I'm also telling you that if you want to start manipulate on things, you have to make them also const expr. And again, this relates to what I've mentioned, that this is a compiler code. Yeah, go ahead, Michael.
Dennis.
Dennis, sorry.
It's okay. So I cannot reflect on the runtime variable, but I can reflect on the type of the runtime variable.
Yes, exactly. Yeah, that's great way to phrase it. Thank you. So I hope that I hope the camera captured that. I cannot reflect on a runtime value variable. I can reflect on the type of a runtime variable. Go ahead.
Yeah. So
I'm sorry. What's your name?
Chris.
Chris.
So I guess so that I understand here. So in this case here, we're using this in a value context, and the actual underlying value itself is context for, and that's what makes
exactly.
This like so if we had A itself not be context for, it would be okay to reflect on the type of A, but then this
exactly just like in the first example that I showed a few slides ago. Exactly, that was what I was trying to.
So that prints 84.
Yes. Like kind of works.
Because we didn't say type name before.
No, type name. Leave the type name out because the type name relates to the splicers. Type name relates to the splicer, and it's in this context. You don't need to disambiguate. So leave the type name out. But yeah, that's what happens here, unless unless I have a bug. But generally. Yeah, so sorry I spoiled the animation and gave you the answer, but yeah, go ahead, Z.
So what is this like represented as like a union? Like if you have like a dependent expression, are you representing like the actual syntax underneath the dependent expression, or does it actually know what it is?
I'm not sure I understand. What do you mean? Okay, so you have a dependent expression, like let's say t equals type. Yeah.
Right. So that could be either a type or it could be a value depending on the dependent context, right? So are you representing the actual like AST of the dependent expression, or are you representing the
all right, yes. So, okay, let me address this question really quick. So first of all, you see here, the restriction regarding values, if you look at the non-type template param restrictions, we're taking, there's inspiration coming from there. And that's exactly the limitations that no, not me, but implementers and authors of this proposal found out that they make sense to make, at least at first stage. And that's exactly what's like the similar things that you can do with and non-type template param, you can reflect on other than that. No, you can. And you can, by the way, you extract a value. I'll show, there's a function to extract a value. And you can also use value with structural type that is permitted result on const evaluation or something that we're probably familiar with more as NTTP to extract the value from. I'm sorry, I just want to run. I don't have a lot of time and I have so much things to say. So let me continue and then we'll go back. I've promised non-trivial things. So let's look at non-trivial things. So we have stud meta info. I'm sure I don't know. I've defined I declared this class R. I'm sure I don't need to tell you, but I'll still say it anyhow. So complete type is a thing that the compiler knows how it looks like, right? So the class R that I just defined there, declared, is not complete type, right? So I'm taking a reflection expression of this R, and I'm I'm giving this stud meta info object here, and I'm executing the meta function. What am I going to get? The meta function is complete type, just like traits, right? It do what it says it does. So what am I going to get here as an answer?
Error.
False.
Yes, great. That was not the trick question yet. That's not the non-intuitive part. But I like how you all being so cautious.
Question, so does is complete type
yes.
Have all the side effects that you get, for example, when you need to query if a type is complete? Like, for example, on MSVC, if you need a type to be complete in point in the program, from that point on, you cannot change the inheritance model of that type anymore, so
I will. Okay, I got a question from a compiler implementer. I'm not a compiler implementer, but I did get a question about, is this same restrictions once I basically call is complete type, I create the same restrictions that I do. So let me finish this example that tries to address exactly what you're saying, and maybe your questions extends on that. So so I have here the declaration you've seen. We have the definition. Now I have a complete type, right? So I'm doing the same thing here. I'm taking in line 14 res2 a reflection expression, and I'm asking, is this a complete type? What am I going to get?
Yes.
True. Yay. Now I do the same thing in line 17, but I use the expression that I used. Sorry, let me just, I hate this thing. I'm using the expression that I basically took, I captured in line 6. What am I going to get in 3?
False. True.
Okay, cool, yay.
There are 2 options, so one of them is right.
Yes, one of them is right. You definitely covered all the space of possible answers.
Undefined behavior.
Yeah. Oh no, no. That you know what? Let me. Yeah. So yeah, I have 3 prints. We already agreed all. First one is false. Second is true. How many people think that the third one prints false? Raise your hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Around 12 people. I hope I didn't miscount. How many people think that we're going to get true? Less people. Wait, Matthias, what do you think? No, I'm kidding. Okay, so yes, interesting enough. We're going to get true. What does this mean? I already mentioned the connection between stud meta info to our AST, right? So going back here, I'm sorry, I'm going to avoid this clicker. This thing looks like we're taking stud meta info by value, basically, right? The snapshot of the state of our program. But that's not actually the case. What it does actually do, and that's, by the way, I went with this example to the authors of the proposal and said, hey, look, do you think that's like, maybe we should reconsider? So they don't think we should reconsider. I will also point out that what I'm saying here in regards to implementation is not, the standard never goes into the details of the implementation. So when I say stud meta info relates to AST, it doesn't mean that the compiler have to now use the AST to represent or bring you back the answer. But yeah, the reason is that instead of getting a value here, what we're actually getting is a reference, right? So this is like a reference to the AST. And while and again, hypothetically speaking or logically speaking, and when I go back and ask and query the state of this object in line 17, despite taking the expression in higher level, line, I still get the latest status of this object. So again, I wanted to highlight this.
Technically speaking, if the standard doesn't say what it is, then it's undefined behavior.
No. It does say.
It should say that
it does say what it is.
Yeah. Defined or
yeah. No, I'm not saying it doesn't say what it is. I'm saying that it doesn't say how to implement it, how the compiler implements that. That's a different thing. Sorry if I mixed that up.
But that's
it does say
source code visible side effect.
Yeah, I know. It does say what it we did talk about stateful, the stateful.
So it says that print 3 should return true.
Yes.
Okay.
Not in that words. It doesn't say print 3 from Inbal's presentation in CPP now in 2025.
That's a site that needs to be corrected.
Yes, I agree. I had a question here from Michael again.
So basically, STD meta colon info is like a smart pointer.
Yes, smart pointer or reference to the, in a sense, again, I want to highlight, this is very important to emphasize, not actually to the AST, because no one tells the compiler how to do this, but logically. Okay, this was the first non-trivial. Last question. Sorry, Michael again?
Yes.
Good.
Is there any way to kind of cache the value of the meta info?
Exactly. So that's what I asked. Basically, when I asked, I asked like, hey, maybe we want to do a snapshot. Maybe we do want to capture by value. It turns out, I think this proposal was a result of a lot of discussion between compiler implementers, standard Ds people, and people that care about usability. So I think main objection came from compiler implementers in this case, and I don't really see the reason, because I would just make the main objection, and I hope I don't quote this wrongly in any way, but the main objection was that will require the compiler to preserve more information, that is an overhead for the compiler, etc. My claim is that it only needs to preserve the information if I basically ask that only for
But then it needs to detect that you asked.
I mean, it does read this code.
Because meta info is essentially a reference to the internal representation of the type.
Right, but the compiler sees my program, so okay. Let's continue later.
It needs to parse the program and say, "Oh, you're accessing this later, so I need to cache the type."
Yeah, but it needs to parse the program anyhow.
So you're asking it to do extra work.
I know it is extra work, but my claim is, it's not. You don't have to do this for everything. You only have to do this for things that I queried on. But generally speaking, let's move away from implementation details for this one. Generally speaking, the answer was this creates an overhead. The compiler needs to preserve more information. I think it's perfectly reasonable to capture a snapshot, but that's in a different way, like I don't know, constant expressions, snapshot thing, or whatever keyword. But never mind. Let's leave that aside. So yeah. One first unintuitive. Wow, I'm almost. I wanted to have discussions as well. So let me just go over the slides more briefly, and I would love your questions. But let's try to keep that for short. So fourth part of the proposal, meta functions, right? So I already mentioned a few meta functions were erased, and this is the updated state if you are following closely. But generally speaking, meta function is doing exactly what you'd expect. I've shown you already. If I capture the expression for this thing and I give it to a meta function, I'm going to get back the result, which is what is the name of. Now, anyone recognizes issue? One of the more experienced people that dive deep into C++. It's a problem with name, Ben. You know what the problem with name is.
The output's going to happen at runtime, so there needs to be a string in the binary.
No. That's fine because we can actually that's actually fine, but more focused on
mangled or unmangled name. Mangled or unmangled.
Okay, that you're in the right direction. It's mangled name. Anything else? Locale. Oh, sorry. What's your name? I know I knew that. Braden. Yeah. Braden says locale. All right. More. So generally speaking, names in C++ are context. So do I have a fully qualified name? This is the namespace ... name. Do I have something else? Do I have locale? Do I have right? So you're in the right direction. Name is controversial. Therefore, we modified that into identifier.
What type does this return?
A stud meta info object, and then I just
Identifier of
doesn't.
What's the
identifier of would return string. I'll get. It's on this slide. Okay. Let me just finish the. I'm sorry. It's just like let's try to do this in a. Okay, identifier of right instead of name of. Identifier of is less controversial. We left the space for name the names space for name of and other things that related to name to be addressed later. But so far, identifier of. To answer Shahar's question, what does stud meta functions return? So they can return a string view, like identifier of, you just asked. Or they can return a stud meta info object. Or they can return a vector of stud meta info object, like in the example that we saw in basis of. They can return bool, size t, or source location member offset. By the way, member offset is like a new thing that we added to basically talk about bit fields, etc. And in the proposal. So quite a lot of things going on here. Quite a lot of meta functions. By the way, I forgot to mention all of those return except info besides those three that I mentioned here that accepts a type. Substitute extract also needs type for the template. Cool. So yeah, I hope this addressed your question. And let's move on. Again, use reflection realm with a grain of salt. I made this up. So now I want to focus on two interesting functions that I think are most interesting to think of, especially in this context. First one is substitute. So what does substitute do? So I don't know why. Sorry about the animation. I take here a reflection expression, and I call, this is again stud meta function. I call substitute. I give it stud array representation or student meta info that represents stud array. All right. And then I give this list of params. You might recognize this list of params as the template params that stud array takes. So what do you think substitute is going to do? Let's see if the name works. I already wrote this on the slide, but yeah, go ahead, Dennis. Go ahead.
It will substitute parameters for array and for the template and generate your instantiation of the template.
Yes. Okay. Interesting. So would it generate instantiation of the template at line?
Well, return meta info for the instantiated.
Exactly. Okay, this is really cool. So substitute, let's think of it as preserve the information and in reflection expression 1. And then in line 3, it will actually instantiate. But yeah, cool. Good. That came up. All right. Just to address the same point, let me get back to that. I really want to go over the slides. I know it's a really fascinating topic, but what happens if I substitute with an array of, sorry, that should have been modified. Sorry about that. Let's say instead of std array, I just give this thing like a struct s. Substitute and replace in your mind the std array with lift operator on some struct s empty one, and then this line a list of params. What happens? Error. Okay. What happens with errors in reflection? Interesting question. You might address this in the future. What are our options, by the way? Compiler doesn't compile, UB, or something else that you're going to see, which is awesome. Okay. So yeah, sorry for messing up the slide, but basically if the substitution could fail. So we also get a function that asks can substitute, and then you can use can substitute and then substitute and hope that you've did this and you teach your developers to do so. Cool. Another function that I thought that worth highlighting, and that's actually the second one and last one that I'm focusing on, is extract. So you're now familiar because there was a question on when do we instantiate things. So you're not familiar, so you're not going to be surprised. So I have an expression here I call extract. I give it the template type int because I want this to extract an int. And I give it a function, a meta function that's called reflect value on 3. So what happens if I would have put here just 3? Okay, never mind. Let's... I'll summarize it by reflect value, reflect object are basically our ability to reflect values that are not necessarily const expr, but we do want to use them in const expr, in meta functions. So that's what you have to, it's like I'll say it's like a adapter. Think of it as an adapter. So what do I get back, from expression?
That's 3?
Yes? Cool. Yes, Mike. Oh, sorry. Yes, Ben.
Is reflect value the same as the unibrow operator? Then? Is it doing the same job?
Good question. So it's like, but you don't have to have the thing in const expr. That's exactly the difference. And that's why it's been added, by the way, to interact with those kind of functions.
Those are my questions.
Great. Okay. Awesome. So now we looked at extract and we looked at, I think those are really interesting, right? Those two functions like substitute and extract, they taught us a lot about how this thing works. Of course, if I'll try to pass something that doesn't work, again, I fail. And we talk about how do I fail later. So last thing I wanted to highlight, you've seen things that looks like type traits in the reflection proposal. Type traits can have two, I'll say, you can have type traits from two kinds. One that is basically query, and one that modifies, like remove cbref, right? In this proposal, in this initial proposal of P2996, we focused on only delivering or mainly delivering things that query. And of course, you've seen you can use splice, etc. You can use logic in reflection, but we didn't expose things that modify significantly. And I think by now you understand that what I said before about AST and modifying the state of the program relates to that as well. So, of course, it doesn't mean that we're not going to see in upcoming years more of those traits that can modify or more functions that do more extensive change, but that is one thing that we need to consider. We did put define aggregate, which is a generative function, maybe the only explicitly generative function. Define aggregate used to be define class, is basically allowing you to inject code into your code. And if you look at all the tools that I shown before, you try to use them, you'd see that you have to have this utility in order to define your own struct. Just using all the splicers and everything wouldn't figure out the problem of defining your own class. But okay, cool. But yeah, so I would love to hear from you upcoming years, and feel free to reach out on functionality that can actually modify. And I think that's a very interesting aspect of reflection as we currently have. Another non-intuitive thing, function param names. So that is a proposal by Jagrut and Adam P3096, and I mentioned that at the beginning of the talk. What happens? Yeah, I have 30 minutes. What happens with function param names? So what do we have for functions in C++? We have declarations and we have definition, right? Do I have to have the names of the params in the declaration?
No.
Do I have to have them in the definition?
No.
Okay. Well, good. So far you were with me. What happens if I give one param name and the other one? What if I use different names? Let's start with an easier question. What?
It's fine.
It's fine, right?
You should use a declaration.
Compiler's fine.
Okay, so
you can have more than one declaration at the point of time where you code runs.
Okay, so I have here function declaration with param names first and last. And I have here function declaration, same function, with param names N and ln. I don't remember what they meant. They had a significant meaning, but I can't remember right now. What happens if I basically try to print the param names? By the way, sorry for modifying the lift operator into the double brackets. I'm maybe still not feeling happy with that. But that's supposed to be identifier of. And I call print params, and this is a const eval function, of course, I wrote here as to answer your question. And print param basically doing what you expect, takes a function, prints its params names. So what happened if I call this function here after the first declaration, line 12?
You get first and last.
Right. What happens if I call it here?
First and last.
In and out.
First and last. Okay. Okay. How many people think first and last? Oh, okay. There's hope. How many people think N and ln? How many people think that I'll get empty strings or something? How many people think that this would not compile? How many people? Nice. All right. So I'll tell you the answer in the next slide, but I just wanted to give you a bit of a taste of what we have here. First call, first and last. Second call, N and ln. Let's see what happens. So the options that we have, right? And this is us. Let's imagine ourselves for a second in the standardization committee. We have a few options. First thing, the compile. Oh, by the way, it didn't came up. Compile and no guarantees, like randomly print something according to compiler's implementation. Second option, enforce consistent naming. Basically, it doesn't compile if there is more than one option. Third name, mark as by attribute, like basically say, for all those declarations, this declaration is the one that I care about the names for, just use this one by some attribute or something. Those mainly were the options. Of course, all the consistent names, etc. Other options that you mentioned here were mentioned, but those are like the highlighted options. And we ended up with this. Woo! Okay, so on the one hand, it's cool because, okay, so what happens here is that we have a guarantee that is not in the C++ programming language, right? We don't force our users in any way to be consistent in naming. Then we basically give them a utility later, of course, a few years later, to reflect on this attribute that we haven't demanded any guarantee for. So you have to pick one, and the one that's been picked is this. So basically, what does this mean for your code? If you have a code base and it have names different than declaration, definition, etc., that means that if you wrote a logger library using reflection, it will not compile in reflection. Interesting, right? Yeah. Well, that was the safest option, though. I would point out. Yes, Steve.
What if the types change in an allowed way? Int versus constant, for example.
Oh, okay. CVRFs. I remember we talked about this. I think that for now, the overload resolution doesn't care about CVRFs, and therefore,
right, they're the same.
Yeah. Yes.
I believe reflecting the parameter will give you the decayed type.
Okay.
It's the canonical type. You remove CRFs.
I don't care what the answer is. I want there to be an answer.
You're right as well. You just ignore the stuff when you return the name. You remove CRFs, but you also don't consider them for overload resolution. So it's fine to have different ones. Quickly, Denise.
What if a parameter is absent in the declaration and then present in the definition?
So I think we ended up with just taking, that's a good question. We just took, if the information is there, we'll return it. And if it's absent in one and you merge all the names. If there's a clash, it doesn't compile. If there's no clash, then fine. You get the result. Okay, cool. Let's move on because I wish we had more time, but I've shown you a few really cool things, right? So far we're way more educated about reflection than we were at the beginning of the talk. Reflection logger. So I wanted to put all the things that we saw in the last slides into one thing, and I also wanted to address the whole idea of libraries using reflection. So I just gave you a very, very straightforward and snippet example of code. So we have here a const-eval function to address what Denise was mentioned. We have a function called log members. It's doing pretty much what you'd expect it to do. It takes a std meta info of whatever, hopefully a type. And by the way, you probably need in production code to add some ifs here to make sure that you have what you expect. And then you basically print the name of the type, and then you print the name of the members, just with all the things that we've seen so far, identifier of. Here you iterate on non-static data members of. Of course, you could also have static data members of. This is not part of meta report. Context per value is not part of the meta proposal. It's just an intrinsic extension of EDG. So I give this thing a struct, and I get what expected. Struct, that's the name, and then name, member ID. Cool, works. Yes, you had a question.
I was just going to ask, does this imply that the string views are guaranteed to be null terminated? Using them?
I'm not sure what you mean. I
On
mean,
the previous
it's
slide.
When a meta function returns a string view,
it will be
will it be null terminated?
Yeah, I understood the question. I'm trying to think of like,
That was debated.
I'm not sure,
I don't
but
know what the answer is.
Well,
I think because I can use this in IOStream, it means that yes.
No, that doesn't mean.
No, it doesn't. It doesn't. Right. I'm not sure. Sorry. Okay. Cool. This works. Another really cool library I wished I could show you the details of, but I don't have time. So let me just summarize this with, you could now reflect on args. Or basically command line args. You could write a command line args library. Basically, the whole thing that you need to do here, the important bit, is that you need to put as option, and that's an implementation that I'm not showing here inside of clap. You need to put an option all the types of the params that you have. And then basically, you can read the args, and then you print whatever you print from args that you get from the compiler flag. So that's pretty cool. We haven't seen this before. I will point out that of course, all the examples are in Godbolt links. I will point out that it's not, I guess, a bit more bugs there because you can't, like, there's not enough tooling to start verifying whether the args you're getting are solid or etc. So this is, take this with a grain of salt. Don't take this into your production code. But I still think it's pretty awesome. And I don't have time to go into the details. Sorry. All right. Slide 26. How much time do I have? Oh, no. Customization points. So I mentioned this term before. I have a talk about this. And by the way, the talk is relying heavily on Barry Rasvin paper that also tries to enumerate all the customization points. But generally speaking, customization points are the way that you connect your library and user code. So I have a library code, right? And I have a user have additional information on their types. Like, for example, what you do with swap and an ADL. So I want to be able to basically modify the behavior of the library according to my user information. And that's what, generally speaking, is called a customization point. So you could consider reflection as a potential way to do customization point, because what I can do, I can basically take my library and break this into parts, and basically specialize some of those things. And not mean in template specialization, but just like make this code behave as the way I want it to behave for my user code. But I hope you understand that in a sense, and by the way, this is a summary of the customization points, but in my view at least, this would be quite a heavy tool, right? Because it's not straightforward. You don't say, here's this function, I want to override this like virtual inheritance.
No, but you can define a struct with the command line arguments you want,
right?
And then pass it to a function that will use a reflection in order to parse the command line. So you just define a struct. I want a file name, which is string, and then it will create the command line parsing from that, and that's a customization point.
Right. So what you're talking about is structural copy, which I have in the next slide. But for a second, I want to talk about yes, what I said here. It is possible to use reflection to do things, to modify your library code. I think it's too much of a heavy tool. But what Shahar was trying to point out is exactly this, structural copy. So you take a class, and if you recall, we talked about use cases for reflection at the beginning of the talk. Can anyone shout those use cases?
Serialization.
Yeah. What was else there?
Delegates.
What?
Delegates.
Yeah. What else?
Dependency injection.
Right. You said all the cool stuff. How about like very, very trivial thing?
Enums.
Enums is cool. Getters and setters. How do I use all the tools that we've seen here to add getter or setter into my class? I can't. I need to do a structural copy and add the getters and setters. So, so basically, as you know, in favor of actually being able to get to the entire presentation, I'll skip this example. This example is from Andrew Southern's paper. Metaprogramming came before this large proposal. But the idea is that I need, in order to modify a structure of a class currently in the current tools that we have in the reflection proposal, I need to basically, I cannot add, and this boils down to, I cannot add code in places that C++ doesn't allow code. So scope of a class, for example, cannot execute things like iterate over members of and add those functions, right? So what do I need to do? I need to take another class and add and basically write a new class from scratch that have all the members of what I want plus the other things as well. And that's exactly what I think is the power, but also might not make reflection the best tool, and therefore I still hopeful for us to get more customization points mechanism in the upcoming year. And I refer this to all the committee members sitting here. I want to see more customization point options for us to do. I think it's really important for libraries. Cool. So yeah, I've mentioned all the things that you can do with reflection and all the things that you cannot. Another non-trivial thing that I want to mention, we are used to scopes, right? We have private and public. I have here in private. Can I reflect on it or not? The slide kind of tells you. What happens in line 7? It's a member. It's a prev. It's a private member. Can I reflect on this? What?
It works.
It works. It works. I can even assign to it. So great. Yes. So that's the decision been made. However, we could go things like Java. Java basically had, I don't remember if they kept it until this revision, but Java basically had this way to mark explicitly things that you want to allow reflection on. Let's say I'd add here for lib type, this attribute says like reflect on or something, right? Or maybe I can just do this for an entire file. Anyway, that's not the direction that C++ went to. We are by default enabling, and that's, again, this is a powerful tool. Use this smartly and use this with, with great power comes great responsibility. We talked about function param names. We already said what happens if you have different names. What does this imply for existing code bases? So I have a code base. I wrote a logger library. What happens if I use my logger library without code?
Mayhem.
What?
Mayhem.
Mayhem. Okay.
Error.
Yeah, we said yes, compile error. Basically, it doesn't compile if my old code doesn't comply to the restrictions, right? So that means that there's some significant thing to consider here. reflection is a powerful tool. But if I now decide that I'm going to drop all the other tools and write my logger library with reflection, I need to take under consideration the fact that maybe for existing code, this will not compile because I didn't apply the restriction for param names. So I think this have a very powerful impact on the way we write code in our pipelines. So if we used to have, let's say, a logger library and an application code, and we link them, and we find out maybe on link time that this thing fails because we don't have the proper functions or whatever, or it works and we get the compiled code. And we also can do things like check which versions do I want with versions macro like libraries normally do. So what happened when I have reflection and I use logger, this logger lib is written with reflection, is that I'm going to get the error before that. I'm going to get the error at compilation. And not all CIs, not all pipes or let's say, not all the environments of companies are ready for this specific change. Like sometimes companies deliver a new library in a DLL or whatever, and they can deliver this even for production with a different version. And it's not something that you can do with reflection because you have to look at the compiler code. But the point is that, and the compiled code to reflect on that. But the point is that we may need to change the way we deliver code. We need to reconsider the mechanisms and the pipelines that we currently have, because if I'm used to having the linker saying something, but okay, I now try to link to this new library and I get errors, and that's fine because I know how to handle them. If I just, someone from a different team, not me, someone from a different team, work the logger library in using reflection, something different is going to happen, right? So yeah. Backward compatibility is interesting in this aspect, and I really think we need to take those things under consideration when you use the feature. So I got to the two last topics that I wanted to talk about. I wonder how much time I have. 15 minutes. Okay, we had a lot of questions going on during. Two things you might ask. What about AI? So I showed you reflection code. Reflection is a generative code, right? It's a way to basically generate code based on the code that I already have. But why can't I just take this thing and push it into like some kind of an LLM? And let's say I want a serializer and deserializer. So I will, instead of trying to convince you, I'll just show you a few snippets of what happened when I tried this. I put the generate my type serializer class in a header. You can generate CPP if you want. Based on my type, provide serialize and deserialize methods, and basically taking things into byte buffer and back. So first attempt, I got this non-consistency between the type returned by serialize and the type that deserialize takes. I don't like this. I've asked it to modify. Second attempt, I got memcopy, not very safe for whatever that is not POD. Third attempt, or again, those are iterations. I got something that is a bit more subtle, but basically my deserializer function returns my type. Can anyone here well-experienced developers tell me what's the problem when I deserialize and return my type? My type is just my type, right? Something that I want to deserialize to. What's the problem with this software?
Validation.
Yes. Okay, good. Phew. I was worried there for a second. I have my type. What happens if I fail to deserialize? I have all the members, they're empty. Did that worked? Did I actually deserialize? So yeah, you need to be able to handle those things, right? So either you throw an exception or return a Boolean, return accepted, that we're gonna have a talk about, or actually I think currently have a talk about. This is a more higher level logical error, but long story short, yeah, the one last thing that I try to do is do exactly the same thing in a new code base, in a new project. By the way, I don't know if any of you have used extensions or things like that. They sometimes can preserve information. Like when you close your IDE and reopen this, the client would kind of remember the state that you've been to. So try this new again. I got completely different results. So obviously, I'm not telling you anything that you don't know yet. That's why I asked in the beginning how many of you worked with LLMs already and AI. I do think that AI can potentially solve kind of problems that we're trying to solve with reflection. But there's two main differences to have here. First of all, is that reflection as a feature inherited in the C++ language, unlike, for example, external Like let's say things like Jinja that can generate template. Are you familiar with Jinja? How many of you are familiar with Jinja? There's a question. Okay, not many, but some. Again, I want to ask for the audience have changed. How many of you have tried using extensions of AI in your code? How many of you tried Klein, for example, in VS Code? Do you know what Klein is? They've overloaded the term. We have Sea Lion, we have Clang, and now there's Klein, very famous or very useful extension for AI. How many of you used ChatGPT? Okay, long story short, LLM process is non-deterministic. That means that between different executions, I'm asking the model, generate this serialization code to me. Between different executions of this thing, I don't necessarily know that I'm going to get the same result and not necessarily know that I'm going to get the same errors. I just showed you the errors, not to say that LLMs are not perfect, but to show you the variety of things that I can get, right? And I think it works better when you give examples to the LLM. But generally speaking, there's no guarantees between executions. And all of the things that I'm telling you are as of now. So it's a good point to mention that as part of my role, besides being, in OS internals, as part of my role, I'm trying to integrate more AI tools into our group. And I'm trying, basically, one of the things I'm doing is exploring new tools, trying to have a wider deployment around our, in our company. And there's quite a lot of significant updates there in this world. But as far as now, and I am trying to be on top of the state, we cannot have guarantees regarding the output. And therefore, if you cannot have something deterministic, you cannot fix it deterministically. And that's the power of things like Jinja that I mentioned and reflection. Jinja, by the way, is it's written in Python. You basically give it a template of a file, let's say, whatever program language you want. And it's just parse the thing into the template that you want. This is deterministic. The way LLMs works is not. Second thing that I was sure would come up by now, but I've already prehensively did and added to the slides. Rust reflection. Does Rust have reflection? How many of you? Cool. Z, did you had a chance to work with this? Or?
Yeah, I mean, they have macros that are just kind of reflectionist. But...
Right. Okay, cool. What if you want to do things that are a bit more... Macros are kind of a bit like a templates in a way, but any of you had any experience with reflection in Rust? Okay, so long story short, that's correct what Z just said. There's macros. There's also the scene library. Basically, scene library is is a way for you to inject things into the AST. Okay, so you basically can take the things, tokens of the AST and basically inject or modify the AST according to the program. And you can use procedural macros to basically move from one AST node to another. But in my view, at least, and this is maybe premature, this is, again, invalidating what I said before. I talked about wanting the logic to be focused on the logic of the program that we're writing. And if you need to use reflection, you need to, in order to use reflection, you need to modify your AST, you need to know how it works. And also, by the way, heavily deal with edge cases. I think it's not good enough as of now. However, I will point out that Rust is catching up, and there is a library called Reflect. So it used to be under development. The release was in March 2025. Maybe there were previous releases on a more mature, and this is like the most mature one. But definitely the idea that I've mentioned have came up before. And someone basically wrote a library trying to address this. So basically this handles the use cases, the edge cases, sorry. So it prevents the need to write like boilerplate code, etc. But you still need to modify the AST. And I think by now you're already convinced that from looking at what happens here, that this is not a trivial thing to do. So I hope Rust would catch up. I still think that in a sense, C++ is doing a good job in terms of exposing user interface and usability. I do hope for them to catch up. And last thing I wanted to mention, I do think that those two languages have a lot to learn from each other. We're basically now in the process of starting a unified committee between, unified group, a study group, for Rust interoperability with C++ in general, and also just to be able to to have productive discussions. So I think it's awesome. Still, in my opinion, not having the same powerful user interface that we have. So to summarize, what can we expect from reflection libraries? We already seen that we cannot expect compatibility with old code. We cannot expect also, and that's explicitly specified, compatibility between standard versions and even between versions, because if you're now reflecting on standard library type, like for example on vector, keep in mind that we make no promises, just like in the sense of param names. We make no promises because you're now getting into the realm of internal implementation. How is error handling is happening in reflection? That's actually the last thing I want to mention. We said one option, the program doesn't compile. Second option is UB. We have a third option, thanks to Hannah Desakova. Thank you so much, Hannah. So Hannah made exceptions const expert. So think about it for a second. Maybe a bit scary at first. We now able to throw exceptions from the basically from the reflection code. Those cannot leak to runtime. Those are not runtime exceptions. But when you can throw an exception, you can give an explicit error message and you can debug your code. And this brings me to another point. Reflection is like a meta language built on top of C++. We need to be very mindful of the fact that people writing this code are going to be needing to take this under consideration, because the question when you get an error is, does this error comes from reflection or from my C++ code? And that's an important question. Yes. So thank you very much, everyone, for listening so far. We have like less than 5 minutes for discussion, but I wanted to thank you all, and I want to encourage you all to reach out to me. As I mentioned, is my interest library evolution, and naturally as being the chair, I do want to hear about future reflection libraries that you'd like to see in the standard library, and please feel free to reach out to me and email me. Last thing I wanted to mention, Daisy Holman, she's also from the standards committee, recently gave a talk just 2 months ago in ACCU, and she recently joined Anthropic. So if you're in the world of AI, you might have heard on Anthropic and their model Claude that works really well for code generation. There's Claude 3.5 and 3.7. And that's really cool. So if you want to learn a bit more about how LLM works, please see those slides. And I really think it relates because, in a sense, what's going to happen in the progress of LLMs going to impact how we write not just reflection, but which features do we add to C++ in my mind. So yeah, I hope you're excited as I am about reflection now. And as I said, landing in 26. And thank you for everyone here listed. By the way, Hannah is also the chair of ST7, which is the group that incubated reflection. That's const expert in charge, the group within the standard that in charge of compile time and incubated this proposal. Thank you for all the people that reviewed my slides in previous versions. And of course, thank you for reflection papers authors, both the original paper and the ones that with the follow-up fixes. And thank you for being so passionate about C++. Thank you. So we have like 2 minutes. Feel free to email me. Ben, go ahead.
So meta info, I can get that by reflecting on a type or
value.
A value,
context
or a template, or a bunch of different things.
Right.
How do I know?
You call the meta function. You call them just like traits. You call a meta function, just like you would with.
Because there are some meta functions which are not presumably not valid. What happens if I reflect on a value? What happens if I reflect on a template, and then I say, give me the type of that meta?
Right.
What happens there?
That's a good question. So Ben asked. Okay, so my answer have 2 parts. First of all, there's quite a bunch of all kind of Boolean indicators, like for can substitute, for example, that we also have that I didn't show here because that would be too long. But they're all kind of indicators that in some cases you want to call first whether this thing works, and that's the first answer. The second answer, I hope you're going to get context for exceptions for the specific use case. Otherwise, you're going to get code that doesn't compile. And I would really hope that you're not going to get UB, but I need to go over the list of things and make sure that we did it that way. But that was definitely the intention.
And those is functions, they're constant eval?
Yeah, they're all traits.
Switch over them or something?
Yeah, you can, just like you could use everything you've seen here, it's all part of the meta info namespace. Sorry, the stud meta namespace. Go ahead, Mike. Dennis.
Yeah.
I got your name eventually.
Two really tiny ones.
Yeah.
Can you splice? So you said you cannot reflect on the runtime values. Can you splice a variable?
If it's context per one.
So
no, first of all, no. You cannot splice. You can splice a meta stud meta info object that represents a context per variable.
If it's not like if I have a parameter that's not context per, so I get a standard meta of.
No, but you can call reflect value. That's I've mentioned this before.
So I can reflect value runtime variable, and then I can splice that, and it will give me the
runtime variable might be a bit misleading in this context, but not non-context where you could use reflect value, but only for limited, like you've seen for the int, but not for
The second one.
Not something you're reading from the user in runtime, because I hope you understand why.
You had in the slide, was the iteration, you had stud meta info assigned in the loop.
Right.
So stud meta info doesn't have to be context per.
No, it's not.
Okay.
Oh, I see what you're saying.
There's a template for it.
No, that was spliced back. No,
you had 4 auto members.
No. I assigned into the member after I spliced it. Let me go back to that. But I assigned into the member.
Yeah.
I assigned into the.
It's a dot pipe symbol or something.
Yeah. Let me see. I assigned into the spliced
when
thing.
You had logging.
Oh, I'm not sure. I need to go back and look at it. I'm sorry.
It was a template for a loop. It wasn't a normal for a loop. So.
Yeah. Ben, go ahead. Oh yeah. Sorry, Mikhail. I think I need to finish. So let's take this as the last question.
Can I reflect the coroutine?
Wow. Okay. We have a proposal for context per coroutines that haven't landed in 26. Okay. Let me put it in one word. It's complex.
I understand.
Yeah. So I hope that addresses that. Yeah. Okay. Cool. But maybe in the future, Ben.
If type info is meta info is kind of an AST representation, can that differ between compilers? What happens if I reflect a lambda?
Right. Okay, so again, I use this as sorry, I forget the word in English because I'm not a native speaker, but I use this as a as a guideline or as a logical equivalent. No. In any way, in no point the standard says anything about the AST. We don't even care about we don't address compilers. So what we have to have as a guarantee is that the implementation will work as expected, and that the outcomes that you can splice, etc., all the observable aspects of it will, but not about the implementation underneath.
So if I reflect a lambda.
Mm-hmm. You know more about lambdas than me, by the way.
Lambdas doesn't have data members, right?
What?
Lambdas they do. It's not specified what. It's not specified what they are.
They do not have layouts. They do not have to have data members.
They don't have to. So reflecting a lambda lets you see the internals of the implementation of how the lambda is implemented.
Exactly.
But just like any other.
That's not portable.
Right.
Yeah.
Wait, okay, so I mentioned this. I mentioned this a few times. I want to repeat this because I just think it's really important. Everything you have in, definitely in the standard library, definitely in the standard, and others people code. If you reflect on that, there's no guarantees. Let me finish with this sentence because I think it's important enough. No, Shaka, let's. We're taking. No, I mean, I don't mind. Okay. Thank you very much, everyone, and let's have a discussion afterwards. Feel free to reach out to me, and thank you very much. No guarantees.
That's not true.